Morning, myself Varaprasad. Today I'm going to explain about various processes with derivations of work and heat in thermodynamics. Before we begin with our processes, we need to know what is heat and work. So heat. Heat is a form of energy transfer that occurs due to temperature difference between a system and its surroundings. Work is the energy transferred by the system as a result of mechanical processes such as expansion or compression. Relation between heat and work. From we should know that from the first law of thermodynamics, it says that change in heat is change in heat equals change in work plus change in internal energy. Types of processes. There are seven types of processes, which are constant volume process, constant pressure process, constant temperature process, reversible adiabatic process, polytropic process, throttling process, free expansion process. Constant volume process. From Gay-Lussac's law, we know that volume is constant by which pressure is directly proportional to temperature and which gives us two relations which are T1 by T1 equal to P2 by T2 and T2 by T1 is equal to T1 by T2. Work derivation for work done. We know that work done is the product of pressure and volume. By deriving, we get work equal to zero, heat. From the first law of thermodynamics, which is change in heat is equal to change in work plus change in internal energy. As the work is zero, we have this relation that change in heat is equal to change in internal energy. Constant pressure process. From Charles' law, we know that pressure is kept constant, by which we get a relation volume is directly proportional to temperature. And for work done, we know it is the product of pressure and volume. By integrating pressure and volume with V1 and V2, we get this relation P2 V2 minus P1 V1, and we know that P1 V1 is equal to MR T1, and from this relation we can expand as MR T2 minus MR T1, and we get work is equal to MR T2 minus T1. Heat. From first law of thermodynamics, that is change in heat equal to change in work plus change in internal energy. We expand this by MCP T2 minus T1, which is for work, and for internal energy we take MR T2 minus T1, and taking the common terms we get MCP T2 minus T1, and we get the relation for heat which is MCP T2 minus T1 in constant pressure process. Constant temperature process. From Boyle's law, we know that temperature is kept constant, by which we get a relation pressure is inversely proportional to volume, and from which we get few relations which are P1 V1 is equal to P2 V2 and P1 by P2 is equal to V2 by V1. For work done, we know that work is the product of pressure and volume. We take this relation PV is equal to constant and we send the terms by which we get P is equal to C by V, and from this relation we integrate and we will get the relation which is P1 V1 ln V2 by V1. Simplifying the terms, we get MR T1 ln P1 by P2 in terms of pressure. So we will have this relation for work which is MR T1 ln P1 by P2, which is in terms of pressure. For heat, from first law of thermodynamics, which is change in heat is equal to change in work plus change in internal energy, where internal energy is equal to zero, and we will have this relation change in work is equal to change in heat. Reversible adiabatic process. We know this relation that PV is equal to gamma, where gamma's value is 1.4, which is also called as adiabatic index. For work, we will take the same relation, which is uh, integral product of pressure and volume, and by simplifying the terms, we'll get this relation C by V to the power of gamma, and if we integrate this, we'll get P1 V1 minus P2 V2 by gamma minus 1, and further simplification gives us MR T1 minus T2 by gamma minus 1, which is the formula for work heat. From first law of thermodynamics, change in heat is equal to change in work plus change in internal energy. In this process, heat is zero, and we'll get this relation which is change in internal energy is equal to ch- change in work, which is the negative symbol which indicates that work is done on the system. Polytropic process. In this process, we will have this relation which is PV to the power of n is equal to constant work, which is product of pressure and volume. And simplifying the terms, we'll have this relation P is equal to C by V to the power of n. And integrating it gives us this relation mr T2 minus T1 by n1. We'll have work is equal to mr T1 minus T2 by into n minus 1. For heat, from first law of thermodynamics, which is change in heat is equal to change in work plus change in internal energy, and simplifying the relations, we will get gamma minus n by gamma minus 1 into work, which is the formula for heat. Throttling process. In this process, work and heat both equals to 0. Free expansion process. In this process, work and heat are also both 0. Thank you.